Hello and welcome. Today, we're going to talk about phased migration with bulk synchronization. If you watched our previous video about PLM data migration, you're in for something interesting. Whether you're already familiar with this or it's new to you, get ready for a quick look into the details. Let's begin. We'll go over a timeline for moving sample data like we discussed in past videos and discuss the good and not so good things about this strategy. Phased migration with bulk synchronization is an advanced data migration strategy tailored for substantial enterprises dealing with extensive data volumes and intricate interconnections. This approach uniquely facilitates the gradual transfer of projects, accommodating the seamless exchange of large datasets between them. The effectiveness of this strategy is in its capable mechanism, guaranteeing the smooth synchronization of significant amounts of data between source and target systems. This capability enables users to operate in both systems concurrently with minimal disruptions over an extended duration. The strategy adopts a Big Bang user-centric migration approach for each phase, prioritizing the end-user's experience during the transition. However, it's essential to note that the implementation of this strategy comes with elevated costs. Both the development of specialized tools and operational expenses associated with this approach surpasses those of alternative migration methods. Despite its financial implications, the strategy's efficiency and minimized user disruption make it a justified choice for large-scale enterprises with intricate data migration needs. In our discussion, we're focusing on the stages of migration and their associated timelines. We have considered the same sample data across strategies for a clear comparison, noting that all the points discussed are in relation to or in addition to Big Bang data migration approach. During the creation and testing of the tool chain for achieving bulk bidirectional data synchronization, we enter a phase that demands time and attention. Developing a mechanism capable of effectively managing the simultaneous transfer of substantial data in both directions requires meticulous effort. In this context, rigorous testing of the entire solution becomes crucial. The aim is to ensure the seamless operation of the bulk synchronization mechanism and its ability to handle the complexities of the migration process. While this testing approach is time-intensive, it is fundamental for the success of the implementation. In the pre-production migration and testing stage, we conduct a trial run before the actual data migration to ensure a smooth process. Specifically, for this type of migration, we need a test source system that allows us to practice synchronizing a large amount of data in both directions. This ensures that the mechanisms for bulk bidirectional synchronization work effectively. Moreover, the pre-production migration demands active participation from business users who are essential for testing the entire synchronization process from start to finish. Their involvement is extensive and critical in validating the end-to-end synchronization, ensuring that the migration aligns with business requirements and functions seamlessly. Production data priming of this approach is the best as tool chain takes care of migration of mixture of complicated data in either of directions smartly. The process becomes more streamlined for later phases as of the most shared data is synchronized using the tool chain following on-demand migration requests from business users. With tool chain's ability to manage data coexistence efficiently, data priming of later phases could be started anytime. In the production migration phase, the data that was modified or newly created during priming moves over seamlessly. This strategy is efficient because it keeps downtime to a minimum. We initiate the production migration only when we've confirmed that the priming went well and achieved the desired success rate. The focus is on ensuring a smooth and controlled transition of data. In the post-migration support stage, the team collaborates closely with the on-demand synchronization team. Typically, this process involves comprehensive migration validation checks, addressing most issues during the migration and fixing them right away. As a result, a compact team is sufficient for this phase due to the proactive handling of potential issues during the migration itself. For on-demand manual synchronization, only the data urgently needed and not migrated in earlier phases is synchronized. This proves particularly useful for the projects that share most of the data but are in different systems. In bulk data synchronization stage, data that has been changed or newly generated and belongs to the data already migrated is synchronized daily between systems. This synchronization occurs either automatically or is managed by a team of migration engineers. Importantly, this process is carried out without requiring users to request synchronization, allowing them to concentrate on their work without interruption. In comparison to all the other migration strategies, phased migration with bulk synchronization emerges as a favorable approach for large-scale and intricate data migration initiatives. This strategy facilitates efficient bulk data movement through a well-designed migration toolchain and minimizes downtime by ensuring data coexistence during the migration process. The phased approach evolves the toolchain across stages, simplifying later-stage data migration. It proves to be a low-risk option, particularly beneficial for projects with dependencies and transformations, making it well-suited for organizational digital transformation efforts. However, these advantages come with a price, as it stands as the most expensive approach in terms of both development and maintenance. Prolonged resource involvement and the longest implementation time, in comparison to other migration strategies, add complexity that demands continuous expertise. The need for a dedicated test source system and extensive testing across all involved domains is necessary. In conclusion, the phased migration with bulk synchronization strategy presents a comprehensive solution that is ideal for large-scale and complex data migrations. It offers advantages such as minimal downtime, low risk, and adaptability to dependencies. However, it is also the most expensive approach, demanding prolonged resource involvement, and having a lengthier implementation timeline, necessitating careful consideration based on project priorities and organizational resources. Through a thorough evaluation of these pros and cons, you can make a well-informed decision on whether the phased migration with bulk synchronization approach aligns with the requirements of your PLM data migration project. We'll be doing a deep dive into a detailed comparison of all the 4 data migration strategies in our next video. We provide services to these Siemens products, and also, we developed our own SmartPort application to automate issue reports and resolution. Please visit our Team Center and NX helpline, which is free and open to all PLM community. Here you will get instant expert assistance, guidance, and best practices for your organization. You can also email us on below mentioned email ID. Thank you for watching this video.